Welcome to Unit 5, Lesson 3. Let's talk about the equations for functions. We're going to find outputs from different equations. Today we really want to focus on understanding more about this side and this side of the function rule that we're working with, and understanding that a function rule means equation. So what we're after with this, the rule is the equation, or it's the expression that dictates how the input will be affected to be able to give us an output. When we look at this table as an input-output pairs, we need to be able to write an algebraic expression inside of this box to write the rule that takes us from the side lengths of a square to the area of a square. If you recall that a square is a rectangular shape, so the area is going to be equal to length times width. Whenever we look at any kind of a square in the math world, what we talk about, the length of any side is S, and so we would determine that as S would be our input, and our output would be A. So we can say that S would be squared, meaning that S squared would be that we're taking the side times the side, since that's the length and the width. Now, as we go through this, I'm going to do my best to try and make sure that if I have to write a 5, it's not mistaken for an S. We talk about this first input of 8, meaning that we would take 8 times 8, or 8 squared, which would give us an output of 64. 2 and 2/10 to the second power will give us an output of 4 and 84/100. 12 and 1/4 raised to the second power will give us 150 and 1/16. And S to the second power would be S times S, which is S squared. And so we would simply say S squared, or capital A in this case, because that was the area and that's what it represents. So that we see, when we understand the rule inside, we can go ahead and work with the input, and then we can work with to determine that what the output is, and what we need to get from that, or what we need to realize with this, is that we have input terms and output terms. We've talked about them as specific values, but when a letter is used to represent any possible input, we call it an independent variable. So in this case, the input is called the independent variable, independent, and then the output is called the dependent variable, because this output, or this number, the dependent variable, relies directly on the input, so it depends on the input here. So we could say here that A, the area, depends on S, or the area depends on the length of any side of the square, or of the square.